Equations. In part A, we got 1 minus 1 over x squared equals 0. In fact, x is in only one place in this term, 1 over x squared. So let's move this to the other side then. So add 1 over x squared both sides. So that leaves the cancel. So 1 equals 0 plus that is just 1 over x squared. Okay, so we got a fraction on the right. On the left one, we can write 1 over 1. That way we can make a fraction. And if there's only one fraction in the left side and only one fraction in the right side, we can cross multiply and get rid of the fractions. So it doesn't matter which one you write first. So 1 times x squared is x squared equals 1 times 1 is 1. Okay, now when we can use the square root property, so x squared equals 1 means x is plus minus square root of 1, which is 1, so x is plus minus 1. So there are two answers, two solutions, x equals plus 1 or minus 1. Okay, let's do part B. So we got square root of x minus 1 plus 3 equals 5. This 3 is separate and 3 and 5 are like terms, so we can combine them. So subtract 3 from both sides. That leaves x minus 1 equals 2. Okay. Now to get rid of this square root, we can square both sides. Okay, square both sides. So when we square both sides, and if we get, and then we get x value, we need to make sure, we need to check if that is still a solution, because squaring sometimes gives us extraneous solution. That means this, it looks like a solution but not exactly a solution. We'll see. Square both sides, that means okay, we could have done like this here. Then that is x minus 1 equals 4. Okay, now add 1 both sides to isolate x. So plus 1, 5. So we got one answer, but before we declare this is the solution, we need to check, because we square both sides. Okay, whenever we square, we need to be careful. Why I'm saying this, because if you square negative 2 square, and 2 square, we get the same value. But negative 2 and 2 are not the same. So squaring sometimes gives us unnecessary solution, okay, extraneous solution. Let's check x equals 1. So we plug in the original. So square root of 5 minus 1, 4, plus 3, is it 5? Square root of 4 is 2, so 2 plus 3 is 5, yes. So that's the solution. Okay, so let's move to the part C and D here. So in part C, we got square root of x just here, plus 2 equals x, okay. Here we got square root, so at some point we need to square both sides so that this square root is gone. But there's a plus 2, so let's move plus 2 to the other side. That means subtract 2 from both sides. That gives root x equals x minus 2. Now let's square both sides. So this will be simply x equals, square means x minus 2 quantity square. Okay, squaring means whole quantity square, here x. Now let's work on this one, x minus 2 squared. This is not simply x squared minus 4. No, what is this? X minus 2 squared is x minus 2 times quantity x minus 2. Now we need to FOIL, distribute. X squared minus 2x minus 2x minus minus plus 4. So that is in fact x squared minus 2x minus 2x minus 4x plus 4. Okay, so we got x squared means there will be two answers, possible answers. We need to check if both are the answers because we squared. To solve this quadratic equation, we have to make one side 0. Let's move this x to the other side. So subtract x from both sides. So this is 0 equals negative 4x and this x. These are like terms, so we can combine. So x squared, negative 4x minus x, negative 1x, negative 5x, and plus 4. Okay, that quadratic polynomial equals 0. To solve, we can factor. If it does not factor, then we need to complete the square or quadratic formula. So looks like it factors. Let's try. Equals 0. I'm going to write that in the right side. Same thing. X squared is x times x. 4 is 4 times 1. 4. 4 and 1 make 5. And to get negative, both negatives. If we multiply, then we're going to get this back. Okay, this is true. So either x minus 4 equals 0 or x minus 1 0. So the product of two things equals 0 means using the zero factor property. Either x minus 4 0. That means we get x equals 4 from this, and from here we get x equals 1. So before we declare these are solutions, we need to check. Okay, let's check. So what is the original equation? Root x plus 2 equals x. Let's put x equals 4. Square root of 4 is 2 plus 2 equals x is 4. 2, is this true? 2 plus 2 equals 4, yes. So this is a solution. How about x equals 1? Let's plug in 1. Square root of 1 is 1 plus 2. Is this equal to x equals 1, right? Is this 1? Nope. 1 plus 2 is 3, but not 1. So this is not the solution. So we got x equals 4 is the only solution. So we got this solution is called extraneous solution, and this happens because we squares. When we square, this can happen, and it happened here. So last question is now for D. Oh, that's the absolute value. So we need to use the absolute value property. When we get rid of the absolute value, okay, absolute value of anything like negative 2, it just spits out the negative is 2. Okay, and if you have 3, just 3. But when there is the x, we don't know whether x is positive or negative. Okay, that means here is the rule. When we solve, square root of x equals some positive number, because it has to be positive number. Absolute value of some junk equals a, implies either this junk is itself a, or this junk, because when we get rid of this absolute value, if this is already negative, then it should be positive, so that equals negative a. If this is already negative, putting another negative will make positive. Okay, so absolute value of x equals a means either x equals a or x equals negative a. This x could be, in this case, the whole junk. 2x minus 3 is like x. So absolute value of that equals 4 means either 2x minus 3 equals 4, or this equals 2x minus 3 equals negative 4. If this is already negative, then absolute value will make it positive. That's the whole idea. Okay, now let's solve. So add 3 both sides. I mean, we can do the similar steps. Add 3 both sides. Then that will be 2x equals 7. Here 2x equals negative 4 plus 3 is negative 1. Now divide by 2, we get 7 halves, or divide by 2, negative 1 half. So we got 2 answers. Final. We can check, but they always work.